Hi, I am Balasubramanya, smart meter consultant. I'm going to talk to you about the functional requirements for advanced metering infrastructure. These functional requirements will define the minimum functionalities and performance for the advanced metering infrastructure system proposed to be used all over. The main objective of the advanced metering infrastructure is to enable the two-way communication between the smart energy meter and head and system to enable remote reading, monitoring, and control of electrical energy meters like the consumer meter, the feeder meter, the distribution transformer meters, etc., so as to serve as a repository of record for all raw, validated, and edited data. So the sanitized data may be subscribed by other utility function for higher order analysis and billing and collection engine, etc. What are the basic functions of the advanced metering infrastructure? The advanced metering infrastructure system shall help utility to manage their resources and business processes efficiently. The AMI system shall support the following minimum functionalities. Number one, remote meter data reading and configurable intervals. Time of day metering. Number three, prepaid functionality. Number four, net metering. 5. Alarm event detection notification and reporting. 6. Remote load limiter and connection disconnection at defined intervals and demand conditions. 7. Remote firmware upgradation. 8. The integration with other existing systems like the IVRS, the billing and collection software, GIS mapping, consumer indexing, new connection, disconnection, analysis software, outage management system, etc. So like that, we have several important aspects to be considered before we proceed to the further discussion on the functionality. The system shall accurately maintain the time synchronization across all devices to ensure accurate data. The system should support the interfacing with the future smart grid functionalities like the outage management system, the distribution automation including self-healing system, distribution transformer monitoring units, electrical vehicle management system, distributed energy resources, etc. So the communication network shall preferably be able to support the multiple applications. In fact, the main general requirements of a AMI system will be like this actually. A smart meter that is in a single phase whole current, three phase whole current, CTPT operated meters, etc. for consumers will provide based on the radio frequency mesh in license free frequency band, power line carrier communication, or GPRS or 3G 4G communication technology, or combination of any of these technologies as per the site requirement and as per the optimal selection of the user. In fact, the access point transported to the head-end system through the wide area network, while the data from smart meter using the GPRS, 3G, 4G technology shall be transported directly to head-end system through WAN, the wide area network. The AMI implementing agency, we call AIA, shall be responsible for proper data exchange among smart meter, DCU, MDM, HES, and other operational requirements, and also the software and hardware functionalities of the AMI system. The AIA, as I described you, the mainly the implementing agency we call Advanced Metering Implementation Agency, may design appropriate architecture for providing end-to-end metering solution. The AIA is free to decide upon the best solution out of all the available options. However, the entire responsibility of fully functional AMI system shall rest with one agency, that is the AIA, in order to meet the performance levels as given in the documentation supplied by the bidder for implementation of the plan. Main components of the AMI are number 1, the smart meter, number 2, the communication, number 3, the head-end system, number 4, the MDM, the meter data management system, and number 5, the web application with updated online data of consumers, etc. In fact, the optional things are also like the mobile app, that is another important agency to be considered actually, which is a very important requirement as on today to download certain basic requirements and basic needs of the utility. The smart meter, the single phase and three phase whole current smart meter, shall comply with the enclosed specification, that is what we require and what we need, like the IEC's requirements, Indian standard requirements, or any other national and international specification. The smart meter installation shall also be done by employing the Advanced Metering Infrastructure Implementing Agency. After meter installation, the customer identification number, meter ID, its hardware and software configuration, nameplate details, make, type, etc. are also read and also complied with updated in DCU, HES, MDM. So the information would also be updated on the portal app for providing information mainly to the consumer. The communication infrastructure shall either be based on the RF mesh network, PLC, or cellular network, or a combination of these. The communication network shall also be based on suitable standards from International Telecommunication Union, IEC, IEEE, CEN, CENELEC, ETSI for NAN and WAN based network. The communication network shall also provide a reliable medium for two-way communication system between various nodes and HES. The RF based network should also be a licensed free frequency band available all over the world. The engagement of network service provider would be the scope of AMI implementing agency to meet the performance level as given and as understood in the optimal secured way of communication system. Main general requirements implementing agency is to design a reliable interface between the robust communication system and the smart metering application. In fact, one of the most important factor is the network security, which has a very important authorization, and also the controls, the logging of the data, the hardening, malicious software prevention, network security protection, etc. or other features to be discussed. In fact, the data concentrator unit based on the communication network will provide the main data between the smart meter and the head-end system. So the data concentrator unit receives information from the smart meter on a schedule need-based stores in the data, which can be accessed by the head-end system for onward transfer to the MDM system. The DCU provides the central link between the smart meter and the HAS. In fact, like that, probably we have many other things like the configuration functionality, interface of DCU, that is another major requirement to upload the system, and the communication on the DCU itself will also play a major role in understanding the system. In fact, apart from these things, there are certain general requirements like the support of the protocol like IPv4, IPv6 and node-based communication. All the communication network equipment shall be approved by the WPC, which is an agency for the communication system, and also on the network management system as a whole. In fact, functionality and configuration is a major thing that will have an impact on the overall stability of the system integration in a smart network system. The configuration of the HES shall facilitate programming of the following data like the load profile, demand integration period, setting of parameters, prepaid functions, net metering, billing date, load curtailment, number of events, event control, time management, lockout period, password setting, and other scheduled applications. The HES shall preferably interface with the MDM on a standard interface and data exchange model, and interface shall comply with the CIM, XML, IEC 61968 or any other open standard. So the solution shall be the service oriented architecture we call SOA. In this connection, it is very important to discuss about the MDM. The meter data management system shall support storage, archiving, and retrieval and analysis of the meter data. The MDM should also support the future requirement of utility and should support the integration of other smart grid functionality like the distribution transformer, health monitoring system, self-healing system, etc. In fact, the main functional requirements are the asset management, the installation support, the meter data management, the data validation, estimation and editing we call VEE, etc. are most important thing to be discussed, and to be formulated for the implementation of the role AMI plan in the infrastructural application. So when you have all these things together, you have a lot of data with you to analyze several things like meter tampered alerts, communication module health, negative compensation consumption pattern, outage management system, indicative networking system, like that. In fact, most important factor here is the analysis of data, providing a good data system, reporting the data, understanding the data, and making the whole system for the revenue protection management, application and system engineering as a whole. So like that, we have several applications to be integrated into the advanced metering infrastructure. So in the next lecture, I will tell you about the functional requirements in an advanced networking system also. Thank you.